Every day, around 83 million rolls of toilet paper are used worldwide. It is one of the most essential products in every home. But how is a roll of toilet paper actually made? We visited a paper mill to discover how ordinary recycled paper is transformed into the soft bathroom tissue used by millions of people every day. Toilet paper was first developed in 1857 by American businessman Joseph Gaiety, who introduced it under the name medicated paper. During its early years, it was sold in packages of individual pre-cut sheets. Then, in 1890, an important breakthrough arrived with the introduction of toilet paper in roll form. This new design revolutionized the product, making it far more practical, convenient, and accessible. It is estimated that the average person uses approximately 100 rolls of toilet paper each year. Worldwide, that adds up to around 21 billion rolls annually. If all of that paper were completely unrolled and placed end to end, it would be long enough to circle the Earth several times. To reduce the number of trees that must be cut down, the paper industry relies heavily on recycling. However, transforming a hard, rough sheet of used paper into something white, soft, and absorbent is a complicated process that manufacturers have spent more than 150 years improving. Inside this enormous paper mill, high-quality toilet paper is produced using an advanced recycling process that gives discarded paper a completely new life. The production cycle begins with the arrival of hundreds of tons of paper collected from schools, offices, universities, and other large institutions. Every sheet entering the plant goes through a careful sorting process. Workers and automated systems separate office paper, magazines, and newspapers according to strict quality and purity standards. Only paper with the correct brightness, cleanliness, and fiber quality is selected for this transformation. These types of paper contain high-quality cellulose fibers and can be processed more easily into soft toilet tissue. Once the paper has been collected and properly sorted, it is temporarily compressed into large bales. Compacting the paper allows enormous quantities of recyclable material to take up much less space, making it easier to transport and store inside the factory. Now the transformation can begin. In a single day, this facility recycles approximately 220 US tons of paper. The recycled paper is loaded into a machine called a pulper. This enormous industrial tank works like a giant blender, designed to mix recycled paper with water at high speed. The intense movement breaks the paper apart and separates it into its original fibers. A large quantity of water is added because the paper must become completely saturated before its fibers can separate. Much more water than paper is required to create a watery mixture known as pulp. Once the paper and water are inside the pulper, powerful rotating blades begin stirring the mixture. This movement tears the paper into tiny particles and releases the cellulose fibers that originally formed each sheet. The mixing process lasts approximately 10 minutes. As the paper is stirred and broken apart, the cellulose fibers separate from one another, creating a liquid, fibrous pulp. These fibers are long and flexible, which is essential when forming completely new sheets of paper. After the recycled paper has been converted into pulp, any remaining contaminants must be removed. The first cleaning stage sends the pulp through a series of filters and screens that capture large particles that failed to break apart. These screens work much like kitchen strainers. The liquid pulp passes through narrow openings, while larger contaminants remain trapped. Staples, pieces of plastic, adhesive, tape, and fragments of paper that were not fully dissolved are all removed during this stage. Even after traveling through several cleaning machines, however, the pulp still appears dark. That is because its main contaminant has not yet been removed: printing ink. One of the most common ways to remove ink is through a process called flotation. During this stage, air is pumped into the pulp, creating thousands of tiny bubbles. Special chemicals known as surfactants are added, causing the ink particles to attach themselves to the air bubbles. As the bubbles rise toward the surface, they carry the ink particles with them. A layer of dark foam forms on top of the pulp and is continuously skimmed away. Once the ink has been removed, the pulp passes through a series of rollers that squeeze out excess water and prepare the fibers to absorb the bleaching chemicals. Rotating blades then cut and loosen the pulp before it enters the bleaching stage, where its color will change from gray to bright white. Although the recycled cellulose pulp is now clean and free of ink, it still does not look completely white. This is because between 5 and 10% of the incoming raw material may consist of newspaper. Newspaper contains lignin, a natural substance found in wood that creates a yellowish or grey appearance. Removing lignin requires a chemical treatment known as bleaching. This process takes place inside an enormous vessel called a bleaching tower. Inside the tower, the cellulose pulp remains in contact with carefully measured chemicals for several minutes at a controlled temperature. This treatment produces the clean, bright color associated with toilet paper. To achieve the strength and softness expected from the finished product, manufacturers may also combine two types of virgin wood fiber: short fibers and long fibers. Short fibers come from hardwood trees. They give the toilet paper brightness, whiteness, smoothness, and softness. Long fibers come from softer woods and provide strength, helping prevent the tissue from tearing too easily during production and use. The prepared pulp is then spread across a moving surface that travels through a powerful drying system. Most of the water surrounding the fibers is removed, allowing the fibers to bond together and form a continuous sheet. In less than 1 second, the watery pulp becomes an extremely thin sheet of paper, measuring only about 4/1000ths of an inch thick. Once the sheet has been completely formed and dried, it is wound onto enormous reels. These parent reels are giant rolls of toilet paper that have not yet been cut into the smaller sizes sold in stores. A single reel may contain as much as 47 miles of paper. Soon, these massive rolls will be transformed into thousands of smaller rolls, approximately 4 inches wide, the familiar size found in bathrooms. The parent reels are transported to the converting section of the factory. Here, several mechanical operations turn the giant reels into finished toilet paper rolls. The first step is to unwind the parent reels. Specialized machines release the paper at a carefully controlled speed, keeping the sheet properly aligned and maintaining the correct tension as it moves through the production line. The toilet paper used in homes normally includes perforated lines that allow each sheet to tear away easily. This step is essential because it ensures that users can remove individual sheets without damaging the rest of the roll. As the paper unwinds, it passes through a perforating machine that creates small, evenly spaced cuts across the sheet. These perforations divide the paper into uniform sections, usually measuring between 4 and 5 inches in length. The tissue also passes between engraved rollers that press a raised pattern into its surface. This process is called embossing. The pattern is not added only for decoration. Embossing creates small pockets of air between the layers, making the paper feel thicker, softer, and more absorbent. It also increases the apparent volume of the finished roll without requiring a large amount of additional material. In another part of the factory, cardboard cores are produced. 2 strips of cardboard, each approximately 31 inches wide, are coated with adhesive and wound together diagonally. This creates one strong, continuous cardboard tube. The tube is then cut into sections approximately 65 inches long. These long cardboard cores are transported to the winding area, where 2 sheets of tissue from separate reels are combined to produce 2-ply toilet paper. The paper is wound tightly around the cardboard tubes, forming extremely wide finished rolls known as logs. When one log reaches the correct size, a blade automatically cuts the paper, seals the completed roll, and begins winding the next cardboard tube. A small amount of glue is applied to the loose end of each log to prevent it from unwinding. The logs then travel toward a circular saw equipped with multiple cutting blades. In seconds, the saw divides each wide log into 16 standard toilet paper rolls, each measuring approximately 4 inches across. The finished rolls are inspected before entering the packaging area. Rolls intended for commercial buildings may be individually wrapped in paper, while household toilet paper is usually packed in transparent plastic. Depending on the product and the retailer, packages may contain anywhere from 4 to 30 rolls. The packaging protects the tissue from moisture, dust, and contamination, while also making it easier to store, transport, and display. And that is how material that was nothing more than used paper and loose cellulose fibers around 15 hours earlier is cleaned, processed, whitened, dried, embossed, rolled, cut, and packaged before returning to society as brand new toilet paper. Give the video a like if you enjoyed it and share it with someone else who may find it interesting. Remember to subscribe to the channel and turn on notifications so you can continue learning how everyday products are made. Thanks for watching.